Hey all, hey class, welcome back. We are going to talk about variables, assignments, input and output. So in this program, which is from your textbook display 1.8, it looks like it talks about pods and peas and pods, and so easiest way to figure out what it does, let's go and run the program. So we have this program already here, so you can play with it when you have time, or even you can stop the video and do it right now. So let's run the program. It's said press return after entering a number. Enter the number of pods. So let's say 10, and it said I should hit enter. Enter the number of peas in the pod. Let's say it's 3. And it prints out if you have 10 pea pods and 3 peas in each pod, then you have 30 peas in all the pods. So it calculates a number for us. Let's look at the program itself. The first 2 lines of code are exactly the same, like the Hello World program. We have the IOStream directive, we have the namespace. In main, the same, curly bracelets the same, return 0 the same. So what has changed is just within these curly bracelets. First line of code, line number 6. In number of pods, piece per pod, total piece. So let's look at what it means. So what it does is it declares some variables. Actually, there's 3 of them. Basically, it's just it can be break down into 3 lines. They just use 1 line to do, to declare all the 3 variables. They are the number of pods, piece per pod, and total piece. So imagine it's just like you are doing math, right? It's just a placeholder to hold that you don't know that value yet, but you need it to do some calculation. So you give it a name and put it in the program. So you wait for the value of that number because you're waiting for the users to input that number. And then you see the declaration actually start with number of pods. So int is actually a type of variable which expects an integer. So it's just a short for integer, basically. So for the variable, you declare it with a name, or we actually have a keyword called identifier. And then you will assign the value to it. All the programming language has certain rules for what can be a variable name. For C++, it can start with a letter or a underscore, but nothing else. For the rest of the name of the variable, you can use underscore, letters, and digits. And also remember it's case sensitive, so the capital O and the lowercase o are considered different. So you can see in the right hand side the examples. For example, the last 2, part 1, both are part 1, but they actually will mean different things. Not that you want to do it that way though when you write programs. It's actually very important to design, to choose a name that is easy to understand and easy for you to remember what it is. Think about it, after a month you wrote a program, or 2 months, and then someone asks you a question about that program. Can you remember what happened? So I say readability is very important. Not only that you want to be able to maintain the program that you wrote, but also maybe later on you move to another project, your colleagues need to deal with what you've done before, or they need to add some code to change the functionality. You want them to be able to read it. Otherwise, you have to sit down with them forever to explain to them what happened. You don't want that, right? So what is a good name? I give you two examples. I think both of these are fine. Using the underscore to separate the words, or using a capital letter to separate the words. But honestly, as an experienced programmer, I can see that, someone who like to use this name, usually a C++ programmers, is someone who likes this, would be someone who do, I would say, Java, because there's history, basically. So for number of parts, parts as a variable name is actually not a very good way to name your variable, or num, right? Later on you look at the code, you're like, what num is? Number of what? So don't use that. Two ways to assign a value. So maybe let's look back to the code. So you see the first two lines are very simple. It's just cout like hello world. We output two lines, the first two lines here, yes. And then it actually have a cin statement. And then there is the variable number of parts. So what this does is it's waiting for the user to input the number of parts, and it will directly assign the number into this variable. And it does twice, right? So it asks us about the number of parts, and then it asks us about, hey, enter the number of p's in the part, and we entered 3 earlier. So it's this statement that accept the 3 into this variable, p's per part. So the second way to assign a value to a variable is using this, is called the assignment statement. So now we know the number of parts, now we know the p's per part. We just time the two number, 10 times 3 becomes 30. And so we want to hold it in a temporary place again, total p's. So total p's will have the value of 30 in the example that we have used. And you see later on we would use this total p's here and print it out to the screen. So that's what I meant. So cin into the value directly to assign a value, or using an assignment statement to assign the value. Oops, sorry. So IO stream, I want to talk about the first two lines because that's what provided the cout and cin. So we talked about cout in the last video about Hello World. Cin is new to us. I want you to imagine they are just like a stream, a river, a flow that is constantly floating in and flowing out of your program. Why we want to think that way? Because one of the easiest mistake to make is pointing the arrow in the wrong direction. So cout, you are basically printing out whatever is within this double quote into the screen. And so I like to imagine this arrow to the cout side of things. It's like a river, all the stuff that needs to go out to the screen will go to the cout. And then cin, the value that needs to go in will point to the variable name, right? So that's how I remember, so that I don't mistake it, because in this course you would use this statement quite a lot. And remember to always end a statement, in all your code, you end a statement always with semicolon, otherwise you get an error. Want to talk about the escape sequence also, because you see, to format the output, this is the first thing that you will learn, is having a new line. So you see this /end at the end, it will actually print out a new line. So let's go back to the program. you see a new line here. You see that that's a return, right? So there's a new line next, and then it expects the number in the third line. So if you, for example, decided to get rid of this slash n, see what happens. You see the two lines now became one line. I can still do the same thing with the program. It outputs exactly the same thing. It's just the text came out differently. The other sequence are like slash t for tab, for double quote, for backslash. I will let you play with it and make it happen for you. Yeah. So now I would like to add some comments to my program, and maybe clean up the code a little bit, because a program is not complete if someone read the code. I have no idea what it does. So there's two ways to add a comment. The first way is to do it in a block, and so anything that's within this slash star star slash is going to be comments. It means the program wouldn't run it, but it will just stay there. So I would say, for example, if I want to, so usually my general practice is to say, okay, what's the purpose of this program? I calculate the number of P's in all the parts. And then usually I would also say, what's my expected input? And my expected input is the number of parts and the P's per part. And then what's my output? Total P's. But when you hand in homework, for example, you want to also say, okay, this is what assignment. Let's say assignment 1. Yes. P parts is the name. Let's say yes, and then my name of the programmer, something like that. So, and then let's look at the program carefully this time. So we have this variables. We are outputting these two lines. We get the input from the user, and then we do some calculation. So let's maybe just make it easier to read. I wouldn't, in this line of code, I probably wouldn't say too much because they can read it. You don't want to repeat everything, but maybe I would just say, okay, this is where the input variables. Maybe I won't actually. Let's just leave it. I would say this is where people are inputting so user input. So I would actually say it that way maybe. And then here is where really the calculation is, right? 10 times 3 is 30. You calculate the total number of P's. So I would say calculation. I wouldn't even say what it calculates because from looking at the code at one glance, you can actually see what it is. And then here is where it outputs the last 1, 2, 3 lines. So I'll say output results. So then that helps me to understand the program better, or when I want to change this code, I don't have to read the whole thing. I can look at the comments and see where to find. Probably if I want to change how this works, I would just go to, hey, okay, there's user input, there's calculation. Okay, it's where the output is. That's what I want to change. And then I want to show you one way to clean up this output. Actually, I don't like how they program it because it's only printing out 3 lines of code, but then there's like, I don't know, 10 lines of code here. So I would combine I would make one line into one line here so that it's easier for me to maintain it. So how to do it? So for CL, the syntax actually can work this way. I can actually combine it by just having the arrow to follow each other, and then it will still print out the same thing. So if you have 10 p pods, if you have number of pods, p pods, so let's test it out first, yeah, to see if we are right. Sometimes it is better to do it this way instead of changing the whole program and then you realize, hey, it doesn't work, or there's error. So it works, yeah. So it still print out exactly the same line. So we clean up one or a few lines of code. So let's do the second line and 3 p's in each pod. Then, so we will do the same thing. We get rid of the CL, we'll get rid of the semicolon, and it does exactly the same thing. So now it should print out this second line. I'm not going to test it for this one because I'm very sure. So there's only 3 lines corresponding to my 3 lines of output. Let's run it. Okay, it works exactly the same, and I'm happy. Yes. So, yeah, I didn't really explicitly talk about it, but the // actually give you a line of comments. So every line you have to do / in the beginning for the compiler to understand it's a comment. I'm not supposed to run that line. I would invite you to try to do this exercise just like what I did, to get yourself more familiar with how the program works. This is just the slides to explain how I actually clean up the code to the CL statements. You can actually see the one after cleaning up here, but I don't have the comments. I highly recommend that you try to do basically adding the comments and cleaning up the code by yourself from the earlier. That's where it is. I think, yeah, it's in the beginning of the PDF. You will have the PDF also in the module. I think this is actually the end of this video. So see you again soon.